Today, we will explore the most pressing and dangerous challenges astronauts face during space missions. Fire. While space travel presents numerous risks, including the effects of microgravity and radiation exposure, none are as immediate and potentially catastrophic as the threat of fire. Understanding and managing this risk becomes crucial as we plan for long-duration missions beyond low Earth orbit, such as trips to Mars. Let's explore why fire poses such a significant danger and how scientists work to mitigate it. Why fire is so dangerous in space. In the confined environment of a spacecraft, a fire represents a critical danger. Unlike on Earth, where we have various means of escape and firefighting resources, astronauts in space have limited options. Once a fire starts on a spacecraft, the lack of immediate safe havens and the challenges of space environments make it incredibly difficult to manage. This necessity drives scientists to investigate how fire behaves under the unique conditions of space to ensure astronaut safety. Research and findings. To address these concerns, a recent study conducted by scientists at the Center of Applied Space Technology and Microgravity, ZARM, at the University of Bremen, offers valuable insights. This study, titled Effect of Oxygen Concentration, Pressure, and Opposed Flow Velocity on the Flame Spread Along Thin PMMA Sheets, was published in the Proceedings of the Combustion Institute. Dr. Florian Meyer, head of the Combustion Technology Research Group at ZARM, underscores the gravity of the issue. A fire on board a spacecraft is one of the most dangerous scenarios in space missions. Fire behavior in microgravity. The study builds upon years of research into how fire behaves in microgravity conditions similar to those on the International Space Station, ISS. Microgravity introduces significant changes to fire dynamics compared to what we experience on Earth. For instance, flames behave differently due to the lack of gravitational convection, which affects how heat and gases are distributed around a fire. NASA has conducted parallel experiments, confirming that fire in space indeed follows different patterns than on our planet. Initial fire behavior in space. Under microgravity, fires present unique characteristics. Initially, a fire burns with a smaller flame and spreads more slowly. While this might sound advantageous, a fire may go unnoticed for longer, increasing the risk of it becoming uncontrollable. Additionally, fires in microgravity burn hotter. This means that materials that typically wouldn't ignite on Earth can catch fire in space, potentially releasing toxic chemicals into the spacecraft's air. Understanding these behaviors is crucial for developing effective safety protocols. Challenges for Mars missions. As we prepare for missions to Mars, the environmental conditions will differ significantly from those on the ISS. One significant difference is the lower ambient air pressure on Mars-bound spacecraft. This lower pressure offers benefits such as reducing the spacecraft's weight and facilitating quicker preparation for external missions. However, it also requires higher oxygen levels to ensure astronauts can breathe comfortably. This increase in oxygen content introduces new fire risks that must be carefully managed. Latest experiments and findings. To address these concerns, the ZARM team conducted new experiments under the revised conditions expected for future spacecraft. They focused on polymethyl methacrylate, PMMA, commonly known as acrylic. Acrylic is a material being developed for future spacecraft due to its lightweight and durability. Using the Bremen drop tower to simulate microgravity, the researchers varied three key factors: ambient pressure, oxygen content, and flow velocity. Detailed results of the experiment. The results from these experiments provide critical insights. Lower ambient pressure was found to dampen fire, making it less intense. However, higher oxygen content had a more pronounced effect, significantly increasing fire risk. In future spacecraft with oxygen levels as high as 35% compared to the ISS's 21%, a fire could spread up to 3 times faster than it would on Earth. This increased fire spread poses a severe risk to astronauts, highlighting the need for stringent fire safety measures. Implications for fire safety protocols. The findings from these experiments emphasize the need to develop robust fire safety protocols for space missions. Dr. Florian Meyer points out that our results highlight critical factors when developing fire safety protocols for astronautic space missions. By understanding how flames behave under different atmospheric conditions, scientists can better mitigate fire risks and enhance the safety of astronauts during space missions. Future directions and solutions. Several solutions and strategies are being explored to address these fire risks. Researchers are developing advanced fire suppression systems tailored to the unique conditions of spacecraft. These systems include materials and technologies designed to detect and extinguish fires quickly and efficiently. Additionally, safety protocols are being refined to ensure that astronauts are well prepared to handle fire emergencies. Training and drills are crucial for equipping astronauts with the skills to respond effectively to a fire. By improving our understanding of fire behavior in space and developing effective safety protocols, we can better protect our space explorers from one of the most immediate and dangerous threats they face. Thank you for joining us in exploring fire safety in space missions here at Mars 666. We hope you found this information as fascinating and meaningful as we do. Stay tuned for more in-depth coverage of space exploration challenges and innovations. Don't forget to like, comment, and subscribe to our channel for the latest updates. Until next time, keep looking up and stay safe, space enthusiasts.